Hello everyone, we are here to discuss the next chapter in the lecture series for Eduwiser CBSE Physics for class 9th, and the chapter is Gravitation. As per the prescribed NCERT syllabus, we are going to cover what gravitation is, the universal law of gravitation, the force due to gravitation, the gravitational force of Earth, the acceleration due to gravity, mass, weight and free fall. So, these are the basic topics that we would be covering up in this lecture series. And besides this, the book also has a section on Kepler's law of gravitation. So, those laws are actually not a part of the syllabus, hence we will not be discussing them here in this lecture. Even in the book we have marked it out as a special section, and only interested students who want to know about what Johannes Kepler had to say about gravitation can consult it, but it is beyond the scope of the NCERT syllabus. So, this is something that you can take a note of. Now, what is gravitation? Gravitation is generally linked with the incident of an apple falling in the lap of Newton, and that even might not even be true, but that is what it is linked to. So, gravitation, the whole idea of gravitation is generally linked with Newton, but that is not true. Even before Newton, there were scientists who had actually worked a lot on the idea of gravitation, and these included Aryabhat, who was an Indian scientist who described the planetary motion, and Johannes Kepler, who gave his laws of planetary motion much before Newton did. So, both Johannes Kepler and Aryabhat, they talked about the path, the planetary motion, the path taken by the planets, but Newton took that idea and he formulated it to find out the force that acts between any two objects that are kept at a distance. Now, the force acting between any two objects in the universe which are separated by a distance is what is called the gravitational force. And anything that you take in, whether it is in vacuum or whether there is air or there is any medium, two objects which are separated will always experience gravitational force. So, the earth will be experiencing gravitational forces from sun, from the moon, from Jupiter, from Saturn, from all the planets. Similarly, all the planets and stars are also going to get the force, are going to feel the force from earth. How their magnitudes, what their magnitudes would be, and how the planetary motion is actually affected as a result of these forces is something that we are going to study now. Before getting into studying all these things, let us just take a very simple experiment. You tie a round stone in a rope or a string, and you start whirling it around your head. If you try to whirl it around your head, you would see that the path that the stone would cover is a circular path, and the radius of that circle would be the length of the string with which you are whirling it around. Now, when experiments were conducted, it was found out that when this stone is whirled around with a constant speed of v, it still changes its direction at every instant. The direction is changing, hence the velocity of that stone is changing despite the magnitude of the velocity being same. We just said that we are whirling it around with a constant speed. So, the speed is constant, the magnitude of velocity is constant, but the direction keeps changing. Now, when the direction keeps changing, that means there is an acceleration, because acceleration is the rate of change of velocity, and if there is a change in velocity as time lapses, there would be acceleration. So, if there is an acceleration, what do you know from Newton's second law? From Newton's second law, we know that whenever there is an acceleration, there has to be a force that is causing that acceleration. Now, when there is a force that is acting, which is actually causing the acceleration, this particular force acts along the perpendicular direction towards the center of the point, or the central point from which the string is being whirled around. So, it is acting towards the center. The direction of velocity is at all times is in a direction of tangent at that point of the circle. So, when you are moving it around the stone in a circle, at any instant, the direction of the tangent is the direction of velocity. That gives the direction of velocity. Now, what is a tangent? At any instant, that if you can just see the stone being whirled around in this circle, you can see the path that it is traversing. Now, for any instant, you see the black spot, that is the ball. The radius, along the radius is where the force would be acting, and this force, the direction of this force is said to be normal. So, the direction of radius is said to be normal, and at 90 degrees to it, just touching the surface, the circumference of the circle is a line which describes the path of V, and that is the tangent. So for any stone that is whirled around in a circle, the direction of its velocity would always be the tangent at that particular point, and the force acting on it would be towards the center, and this force is called the centripetal force. The magnitude of this force can be easily calculated. The acceleration that we experience when we whirl around a stone with velocity v in a circle of radius r is A is equal to v square by r. If the acceleration is v square by r, that means the force acting on it would be F is equal to ma, where m is the mass of stone. So the force would be mv square by r. So mv square by r is the magnitude of centripetal force that acts on any body that moves around in a circle of radius r with a constant speed of v. The velocity will not remain constant, it will keep changing as the direction keeps changing at each instant, and the direction of the velocity is always the tangent at that point of the circle, or at that point of the path that the stone is taking. Now, if you extend this similar thing to the planetary motions, you would be able to answer a lot of things. When you have the moon taking a round around the earth, it is due to this particular force. This is because of the force of attraction that the earth and the moon have for each other. So the earth attracts the moon towards itself in a direction that joins the centers of the two planets. So it is along the radius, and the moon keeps going along a tangential. It's not completely circular, it's probably a bit elliptical, but even in that path, the direction or the direction of velocity for the moon would always be in the direction of tangent at that point. So similar to that stone whirling experiment, the moon moves around the earth in a circular path, approximate circular path, with its velocity always being along the direction of a tangent and the force acting towards the center. So this particular force that acts between two objects is the gravitational force. So the gravitational force acting between earth and moon would act along the line joining their centers, and the direction of motion of moon would be along the direction of tangent at any point of its path. Now in the experiment that we just conducted with the stone and the string, if you release the string, what will happen to the stone? Would it fall towards the center of the string, or the point from where it was being whirled? No, it will move in the direction tangential. It will not move towards the center, it will move in a direction tangential. So similar to that case, if the force between moon and the earth stops to act, the moon is going to take a path that's tangential to the circular path that it was taking before. So the moon would move in a certain direction. Now when the moon attracts the earth and it moves around it, you would ask, why doesn't the earth also move around the moon in a similar fashion? Now this again can be answered from Newton's second law of motion. Newton's second law of motion also states that the acceleration is given a constant force, the acceleration is inversely proportional to mass. You have F is equal to ma. So A is equal to F by m. If the force is constant between the earth and the moon, the force is going to be constant. So if the force is a constant, the acceleration would depend on the mass. Greater the mass, smaller the acceleration. So compared to the earth, the mass of the moon is very small, so it moves around the earth. But the mass of earth is so high, so large in comparison to the moon, that the acceleration it experiences as a result of the force of attraction with the moon is too low, too negligible to be identifiable. So the earth also experiences the force, but its magnitude, but the acceleration that it faces, it experiences due to that particular force is very small. But when you compare it to the force of attraction that the earth has with the sun, you know that the earth would move around the sun. Now the mass, there will be a force of attraction between the earth and the sun. So there is a force and there is mass of both the sun and the earth. So the earth moves around it because the mass of earth is quite less in comparison to the mass of sun. The sun doesn't move around because compared to the earth, the mass of sun is huge. So for the same constant force that's acting between these two objects, the earth would take a path around the sun, but the sun would not move because the acceleration that it experiences as a result of the gravitational force that is acting between the earth and the sun is too small. So generally you have the paths of the planet as circular or elliptical. So now you know why. It is because of the gravitational force that acts between any two objects of this universe, and the direction of that force would always act in the direction of the line joining the two centers of the objects, just like in case of a centripetal force. And when the force acts in this way, the motion of the body is going to be circular because its path is going to move around like this. So when the velocity is in a direction circular, when the path is circular, this is how it is going to move. So we now have a fairly good idea of what gravitational force is and how the gravitational force acts between the different planets. Just like we discussed about the Earth and the Moon experiencing gravitational force, the Earth and the Sun experiencing gravitational force, the other planets would also experience similar gravitational forces. The acceleration that they experience as a result of that force would depend on their masses. Greater the mass, smaller would be the acceleration. So between any two objects, the object which is lighter in weight is going to take around the other object. So this is true for planetary objects, and Newton formulated his law saying that it's not just applicable to planets and the stars, it's also applicable to individuals, human beings, to everything that's there in the universe. Any two objects are going to attract each other with a force that is called the gravitational force.